Okay, so chapter 2 is on trigonometry, but before we start trigonometry, we're going to do a little bit of review. And the first thing we're going to go over is the Pythagorean theorem, which is an equation that relates the sides of a right triangle. And basically the Pythagorean theorem says that the leg squared plus the other leg squared equals the hypotenuse squared in every right triangle. The legs being the sides that form the right angle, the hypotenuse being the side which is across from the right angle. And it's always the longest side in a right triangle. Typically, the longer side in in any triangle is across from the largest angle, smallest side is across from the smallest angle, and so on. So in a right triangle, the 90-degree angle will always be the largest angle, so therefore the hypotenuse should always be the longest side. So we're just going to try a couple of examples here now to review the Pythagorean theorem. And the first one asks you to find the missing side. So if we use our formula that leg squared plus leg squared equals hypotenuse squared, we have the two legs are 12 and 8, so 12 squared plus 8 squared equals your x squared. And 12 squared is 144, and 8 squared is 64. So then if you add those two up, you get 208 equals x squared. So x would be the square root of 208. If you have x squared and we want to get x, you can square root both sides. And we don't have to consider the fact that x could be negative because in this case x is a side length, which would be a positive value. And you can approximate that. So x would be approximately 14.4. So the next example, we have again a right triangle, so we can use the formula for Pythagorean theorem again. Leg squared plus the other leg squared equals hypotenuse squared. And the two legs in this case are 10 and x, labeled 10 and x, so 10 squared plus x squared equals 15 squared is the hypotenuse. So in this case, the x is not the hypotenuse, the x is the legs, so you'd isolate the x term, which would be x squared, and bring that, 10 squared would be 100, and 15 squared would be 225, so that'd be 225. Take off the 100 from the other side, so x squared equals 125. So then x would be approximately, or would be exactly the square root of 125, which is approximately 11.2. Okay. Alright, so the next practice we're going to try is labeling triangles, because in order to do trigonometry, right triangle trigonometry, we need to be able to figure out which side is the hypotenuse, which side is what we call the opposite, and which side is what we call the adjacent. So the hypotenuse is always the longest side of the right triangle, it's always across from the 90-degree angle, but the opposite and the adjacent sides are going to depend on which angle of reference you're using. So if you're coming from the angle that's marked theta in the diagrams down here below, the opposite is the one that's across from the angle, and the adjacent is the side that makes up, one of the sides that makes up the actual angle that's labeled theta, but it will be obviously the side that isn't the hypotenuse. One of the sides will always be the hypotenuse and the other one will be the adjacent. So we're going to just get some practice in labeling the opposite and the adjacent and the hypotenuse in right triangles. So in our second example here, our hypotenuse would be the one that's across from the right angle, so that would be the hypotenuse. And our opposite is the one that's across from the angle of reference that we're talking about, so this would be our opposite side. And the side that makes up the angle that isn't the hypotenuse side would be called the adjacent. And the in the next example, the side that's across from the angle is called the opposite. The side that's across from the 90 is your hypotenuse. And then the side that makes up the angle, there's your angle that you're talking about. And this side is the hypotenuse, so the other side is the adjacent. So now you're going to practice some examples here of labeling the sides. So again, you should have this being the opposite because it's across from the angle of reference. The one across from the 90 is the hypotenuse. And the side that makes up the angle of reference and isn't the hypotenuse side will be called the adjacent. And in B, the one that's across from the angle is the opposite. The one that's across from the 90 is the hypotenuse. And the one that's across, that makes up the angle, side that makes up the angle of reference, theta, right here is one of the sides that makes up angle that's marked theta. That would be the side that's called the adjacent. The other side will always be the hypotenuse. And again, the last one, you should have this one as the opposite. This is across from the angle. Across from the 90 would be the hypotenuse. And the other side that makes up the angle would be the adjacent. Alright, so now we're getting into the tangent ratio, which is one of the trigonometric ratios that we're going to learn in this chapter. And trigonometry is basically the study of the properties and applications of triangles. So we're going to be doing right triangle trigonometry, starting off with the tangent ratio. And the tangent ratio is defined as the ratio of the opposite side over the adjacent side in reference to a given angle theta. So opposite over adjacent. So if we're talking about this angle here as being our reference angle, then the opposite would be the side across from that angle. The adjacent would be the side that makes up that angle that isn't the hypotenuse side. So we're going to use that definition now to find the tangent ratio for each of the triangles in the examples below. So the first example we have, A is our angle of reference, and we want to find the tan of angle A. And just till you get used to the definition, you should probably write it down a few times. That tan of an angle is opposite over adjacent. And that would be, in this case, opposite angle A would be the side marked 3. And adjacent to angle A would be the side that makes up angle A that isn't the hypotenuse. So these are the two sides that make up angle A. So the one that isn't the hypotenuse is the one with a measure of 4. So the tan of angle A would be 3 over 4. Tan of angle C now would be using the same diagram again, but this time we're coming from angle C. So opposite angle C would be, this time would be 4. And adjacent to angle C would be one of the sides that makes up angle C that isn't the hypotenuse, so that would be the side marked 3. So the tan of angle C would be 4 over 3. We're looking at the next triangle here on the right. First one, tan of angle A, so we're coming from this angle right here. So the opposite would be across from angle A, which would be 7, over adjacent to angle A would be this side here marked 24. And tan of angle C would be in angle C. So opposite angle C would be 24. And adjacent to angle C would be one of the sides that makes up angle C. These two sides make up angle C. And the one that isn't the hypotenuse is the one with 7. Measure of 7. So the tan of angle C would be 24 over 7. The next example, A. Opposite A would be 12, and adjacent to A would be the side that's right here, because this one is the hypotenuse, this side here. However, we don't know what that is, so the first thing we have to do is figure that out using Pythagorean theorem. So we know that x squared plus 12 squared gives you the hypotenuse squared of 13 squared. So x squared plus 144 is is 169. Now if you know your Pythagorean triples, you know the answer to this is going to end up being 5, but if not, you'll have to work it out by isolating the x squared and getting x squared is 25, which means x is the square root of 25, or 5. So therefore the tan of C, just erase this, the tan of C now, we're at this angle now, and across from C would be x, so opposite C would be 5, and adjacent to C would be the 12, because we know the 1 mark 13 is the hypotenuse. And in the last example, again we're going to have to figure out a missing side. We may as well do that first. So we've got x squared, leg squared, plus the other leg would be 8. Those are the two sides that make up the right angle, equal to hypotenuse squared, which is 10 squared. So x squared plus 64 gives you 100. So x squared equals 100 minus 64, which means x squared is going to be 36, which means x is the square root of 36, or 6. So if we're looking for the tan of angle A, we're right here. And tan of angle A would be opposite, which would be the side that we just figured out, which is 6, over the adjacent, which is this side right here, because the other side that makes up angle A is the hypotenuse. So that'd be 6 over 8. And both of those have a common factor of 2, the numerator and denominator of that fraction. So that means 2 goes into the top 3 times, and it goes into the bottom 4 times. So we can reduce that fraction to 3/4. And the last one, tan of angle C, would be from this angle right here. So opposite angle C, let's mark those off a little bit. Opposite angle C would be the side marked 8, over adjacent angle C would be the side that we worked out at the beginning there, 6, and those both are divisible by 2, so that would become 2. 8 divided by 2 is 4, 6 divided by 2 is 3. And that's it for that page. Okay, so now we're going to learn how we can use a tangent ratio to find missing information in a triangle. You can use the tangent ratio to find a missing angle if you have the opposite and adjacent sides. And you can also use a tangent ratio to find a missing side if you know an angle and either the opposite or adjacent to go with it. So we're going to start off with examples where we are looking for the angle. The first thing you need to make sure is that your calculator is in degree mode. There should be a button in your screen. Most calculators, regular calculators, scientific calculators, usually on the screen there will be a little D indicating that it's in degree mode, just a small D up at the top of the screen somewhere, or it might have DEG for degrees. If it has a G or an R, that means it's in gradians or radians, so you're not in the proper mode. If it has RAD or GRAD, that's radians, gradians as well, so that means you're not in the proper mode. So you should have either a button that says DRG for degrees, radians, gradients, or and change it to degrees, or you might have a mode option on your calculator, so you'd go into degree mode. If you're not sure how to change it to degrees, you should make sure you check with me, and I can show how your calculator is, what you need to do with your calculator to figure out if it's in degree mode. Okay, so let's try a few examples here. So there's 3 basic steps. First of all, you got to kind of look at your diagram and decide what side you have, which is the opposite, which is the adjacent, which is the hypotenuse, that sort of thing. And then you got to set up your ratio and then solve your equation using the method I'm going to show you now. So the first example there, again, make sure your calculator is in degree mode. You've got this angle, theta, is the one you're trying to find, and in trigonometry we use, a lot of times I'll use Greek letters to represent angles, and this is one that's commonly used, the theta symbol. This is your theta symbol right here. Okay, so what we do is set up this here, would have tan of theta would be opposite over adjacent. So that means that tan of theta is 4, is the opposite, over the adjacent is the side marked 3. So when it's like that, basically the thing you don't know is what the angle is. So we would have to then find the angle using what we call the inverse tan operation on your calculator. So if you take your calculator and put in, some calculators you have to put the 4 over 3 in first. So 4 divided by 3, and then hit the second function of the tan key will give you that. And some calculators you have to put the inverse tan option first, so this is usually the second function of the tan key, and then hit 4 over 3 and close your bracket. So that would be 53.1 is what the calculator gives you back degrees. So theta is 53.1 degrees. So our next example, theta is down here. So if we're going to set up our equation, we know that the side we have is the opposite because it's across from the angle, and the other side is the adjacent because it's a side that makes up the angle, but it isn't the hypotenuse side, so we know that it's the adjacent to that angle. So the tan of the angle is opposite, which is 35, over adjacent, which is 50, and that means now that our angle, equals inverse tan of 35 over 50. And if you put that in your calculator, you get 34.99 degrees, or approximately 35 degrees is the measure of that angle. And this example here, we have, there's our theta. So the sides that we have are again the opposite, is the 75, side mark 75, and this side here is the adjacent. The side we don't have is across from the 90-degree angle, which is the hypotenuse. So we do have enough information to use tan. So if we set tan of the angle equals 75 over 35, then we know that the angle is inverse tan of 75 over 35, which is 64.98 degrees, or approximately 65 degrees. Alright, the next example is a description of a rectangle, and it says that the dimensions of the rectangle are 20 by 30. Determine the measure of the angle created by the diagonal and the longer side. So we're going to just sketch a little rectangle here first, and we know the dimensions are 20 by 30. And the diagonal would be the line segment that joins non-consecutive vertices. I don't know why. Can't draw a straight line diagonally for some reason, so you'll have to just pretend that that's a straight line. It should not be curved. Anyway, that's the best I can do there, sorry. So you are looking for the measure of the angle created, the measure of the angle, that's the measure of the side. You're looking for the measure of the angle created by the diagonal, so this is diagonal, and the longer side. So that would be here or up here. But they would both actually be the same, because you know that the opposite sides of a rectangle would be parallel, and these would be alternate interior angles, so they should be the same measure anyway. So it doesn't matter if you put it right here or up here in this spot. So we're going to keep it where we have it. So that means that if this is 20 by the properties of rectangles, this should also be 20. And then if we concentrate on this right triangle, because the angles of a rectangle are right angles, so we know we have a right triangle here, and we do have the opposite and the adjacent of our angle marked theta in that right triangle. So we can use the tan of angle theta is opposite, which is 20, over adjacent, which is 30. So that means the angle is the inverse tan of 20 over 30. You use your calculator then. Inverse tan of 20 over 30 is approximately 33.69, or approximately 34 degrees for angle theta. So example E, a driveway is built on an incline so that it rises 3 meters over a distance of 20 meters. What's the angle of inclination of the driveway? So the first thing we want to do is draw a diagram. So it rises 3 meters over a distance of 20 meters. So if this is 20, then it goes up 3. Now the angle of inclination is an angle that's measured from a horizontal up. And usually start from wherever the reference point is that they're talking about. Draw a horizontal line if there isn't one given, and then measure up from that horizontal line. If it was an angle of depression, you would start from your reference point, draw a horizontal line out from there, and measure down from that point. In this case, we're doing an angle of inclination, so we're going to be measuring up from our horizontal. And there's our line that connects the angle of inclination. After we move up from the horizontal, that will give us the angle of inclination to be right here. So then if we're looking for that angle, we do have the opposite, because this would be a right triangle, because you would have a vertical and a horizontal line which would meet at a right angle. So this would be the opposite, and this would be the adjacent side to that angle. So therefore we would have enough information to use tan again. So tan of the angle would be opposite, which in this case is 3, and the adjacent would be 20. So then if we use our inverse operation to isolate the angle, we've got angle is inverse tan of 3 over 20, and use our calculator to work that out. And I always put brackets around my fractions because I use the division I never use the fraction option on my calculator. So if I'm using inverse tan, second function of the tan key, and then second function of tan key, then I have bracket 3 divided by 20 bracket, because I don't want the calculator to actually find the inverse tan of 3 and then divide that answer by 20. So you've got to have that fraction in brackets there. So that will give you, just move that up, 8.5 degrees around there approximately. And that sounds reasonable for a angle of inclination of a driveway. So these are some questions down at the bottom here now that we can try on pages 75 to 77 in your textbook for extra practice on this material.